Welcome to week 2 of statistics at Blue Mountain Community College. I'm Gary Parker, and I just want to give you a quick update on what we're doing this week. The practice assignment isn't quite ready, so it's password protected. Once I'm done editing those today, I will take off the password. Quiz will have a password on it similar to last week. I'll post that password. That one has a password because it's timed. Application 2, I'm still editing. I'll get that posted soon. So for now, start on the reading and playing around with stuff in the book and checking out the videos. Big ideas for this week is we're going to cover sections 2.2, 2.3, and 2.4, and they're mostly about one quantitative variable. So things we measure: height, age, length, braking distance of a car, lots of different things. First, we'll look at shape and center, and then measures of spread, and then we'll compare different groups, categories, based on quantitative numbers in those categories toward the end of the week. So, for example, for the survey you did about the average person, I collected all kinds of information about you as my students. Here I have age data, 602 ages. Minimum age was 16, maximum age was 58, mean or average 25.4 years old, and the median age is 21. So I want to point out something about the mean, the average versus the median. So let's use red for the mean. 25.4 is going to be about right here-ish. I'm just going to mark that with an X. And I'm going to put a bar over the top because X bar is our symbol for mean, excuse me. The mean symbol we usually use, or median, excuse me, the symbol usually used for that is M. So M is 21, so the M is about over here. So that right there is our median. Notice the mean is to the right of the median. The shape of this distribution of data, we would say, is skewed left. The skew is to the tail. All right, I see this tail to the left here. If we look at the data set braking distance for 2020 automobiles, that's the stopping distance from 60 miles per hour on dry pavement, the distribution of data here has what looks like a left tail. So we would say this data is skewed left. And if we look at the mean versus the mean, M, 131, that would be about here. And X bar, the mean, is just a hair lower than that, so 130.8. So just a tiny bit to the left, but it is a little bit to the left. So that's my X bar there, my mean. And these lower values, so these braking distances here are unusually low compared to the majority of data over here. And again, that's called a left skew. And you can have data sets where the skew is not exactly evident. Some might argue, oh, there's a little tail to the left here. Somebody else might say, oh, but there's something going on over here. Maybe the tail is to the right. There are calculations for skew. We're not going to worry about it in this class. When I look at this graph right here, this graph seems to have what we call a bell shape to it. And it's almost symmetric around this center line right over here. Do a little of that mess. If we look at the mean and the median, those are much closer than the other two that we saw. So they're both pretty close to 7 here. And 7 is being counted in this column right here. So here I have X bar, and M is pretty close to the same number. So if there's not much of a skew, they'll be pretty tight to each other. And these tails pull the mean away from the median. So the median is not as subject to data to the extreme left or the extreme right, but the mean is, because you have to add up every single number to get the mean. But the median is the middle number, regardless of how far out the tail data is. So it doesn't matter whether somebody said they got 14 hours of sleep, the median will still be in the middle. But if somebody had 14 hours of sleep, that would drag X bar toward that right-hand tail if there happened to be data out there. So that's something important to know. Other big idea, so that measures of center and the shape of a distribution of the big ideas in section 2. And there's lots of different shapes. We have this symmetric bell shape here. We have a skewed left shape we see sometimes. We have a skewed right shape we see sometimes, and the skew is to the tail. Next big idea are measures of spread. And I'm only going to touch on one or two of the measures of spread right now, and you'll check out the rest in the text and other videos. Standard deviation is a very important one. And so here I have a calculation of standard deviation for the ages here. And I'm just going to simplify this a little bit. Let's suppose the mean is actually just 25, and to the nearest whole number it is. And then for the standard deviation, I'm going to simplify that. Instead of calling it 9, I'm going to say it's about 10. Okay. Standard deviation is an average measure of spread from the mean. Very important notion to get down. So standard deviation and average measure of spread from the mean, not the median, the mean. So it doesn't make any sense to talk about standard deviation if you don't talk about it in context with the mean. They have to go together. Since it's a measure of spread from the mean, I can only use the standard deviation if I start at the mean. So if I say the mean is 25 here and standard deviation is 1, one standard deviation to the right would be 35. So I'm just going to label that as 1s, s for standard deviation. If I go 2 standard deviations to the right, that would put me at about 45. So that would be 2 standard deviations to the right. If I'm at the mean and I go 1 standard deviation to the left, that would put me at 15. So that would be minus 1 standard deviation. Now, technically, this 35 here is X bar, the mean, plus 1 standard deviation. And that 45 roughly is X bar plus 2 standard deviations. But we often abbreviate it and just call it 1 standard deviation or 2 standard deviations. Sometimes we take it a step farther and we just say it's 1. Or 2, or -1. If you're at the mean, you're neither to the left or the right, so we would say that is a 0. If you just count in that way by standard deviations, that's called a z-score. So a z-score just means count standard deviations. There's a formula for the standard deviation. It's rather complicated. What you do is you find the deviation of every number. Deviation is distance from the mean. So that would be, say, some number x minus the mean x bar. So if you were 35 years old, then your deviation would be 10. If you're 30 years old, your deviation would be 5. If you're 20 years old, your deviation would be -5, right? Because you're 5 below the mean. If you try to add up all the deviations, you'll always get 0 because of what the mean is, the average. So we have to square them to get rid of the negative signs. Then we add them up. And instead of dividing by the total number, right, which is what you do for average, for a sample, you take the sample size -1 and divide. Then you have to undo the square by taking the square root of this whole big butt fraction there. That calculation right there is the sample standard deviation, S. On a spreadsheet, it's just STDEV, parentheses, whatever your data is. All right, so you're going to get used to using standard deviation, using it to talk about the spread of the data. Related idea, which I'll go over in another video, is the idea of coefficient of variation. So coefficient of variation, CV for short, is the standard deviation divided by the mean as a percentage. So we multiply that by 100%. The reason this idea is important is suppose you have quiz scores, average is 7, standard deviation is 1. right? The average spread is 1 out of 7. Suppose you have test scores. Average is 70, but the standard deviation is 1. 1 out of 70 is minor. 1 out of 7 is a lot, right? So the standard deviation with respect to the mean has to be considered in a couple of different ways when we're talking about the spread of data. One way is just counting to the right and the left from the mean by the standard deviation. That's the idea of a z-score. And then the other is what percent of the mean does the standard deviation represent? That's called the coefficient of variation, and that's another important thing that we'll look at when we're comparing two data sets. We'll come back to that later. All right, there's a few other ideas in these sections that you're going to play with as the week goes on. Have fun with it and get in touch with me if you have any questions. I'll be in touch with updates on the assignments in another day or so. Take care and do good math.